All right, what you got?
All right. And because all the problems are similar to this, it's negative
Mhm.
5x plus 4 over 3 equals 8 over 3.
All right, and we're just solving for x?
Yep.
Okay. So if you want to get rid of the fractions, one way you can do it, well, the main way to get rid of fractions is to find the LCD of each one of your fractions. In this case, it's just 3. So our LCD would be 3, and then you would multiply each numerator by that 3. So that would be 3 times negative 5x plus 3 times 4/3 equal to 3 times 8/3. All right, so that'd be negative 15x. Now, the reason why we multiply by that 3 is so that these 3's can cancel. That leaves us with 4. And then these 3's can cancel. And that'll leave us with 8. So if you don't feel like working with fractions, you always can multiply by the least common denominator.
You actually that's the only part I was stuck on. You actually just helped me so I can
Okay.
simplify from that afterwards. But thank you. That's what I needed right there.
Excuse me. Okay, not a problem. All right. Um, anybody else before we go any further? Everybody's okay with graphing? In other words, let's say if I have y equal to 3x minus 5, one of the ways that I submit it as a method of graphing is to create an XY chart. You can choose your X values. Doesn't matter what X values you choose them, plug them in to find the corresponding Y value. So in other words, we'll plug in for X to get out Y. So basically, when X is -1, what is Y? So that's what we're going to be doing. So 3 times -1 minus 5. -3 minus 5 is -8. So when X is -1, Y is -8. 3 times 0 minus 5. 0 minus 5 is -5. So when X is 0, Y is -5. And then 3 times 1, 3 minus 5 is -2. All right. So those are our 3 ordered pairs. Now in my math lab, you only can graph 2 points. So you wouldn't have to do 3. I just have a habit of doing 3 because that's what we used to do, without, before the whole graphing tools and stuff, we would always graph 3 points. So I'm just used to doing 3, but all you need is 2 points. All right. So before I go to graph, is everybody okay with what we did, that process? I see somebody copying, so I'll give you a second. All right, so let's graph those 3 points. That line's crooked. All right, so first point, I start at my origin, go to the left 1, down 8. It'll be right here. So that's -1, -8. Second point, that's 0, -5. So I don't move left or right because that's 0 for X. Then I go down 5. That'll be right here on the y-axis. Then here, +1, -2. So I'll go to the right 1, down 2. And that will be my line. All right. Everybody okay with that? Another method that was in there was graphing. So this method was just creating an XY chart. Second method I mentioned was graphing by using your intercepts. So let's see if I have 5x minus, do I want to go 6? Let's go 4y equal to 20. 5x minus 4y equal to 20. So if you want to find your x-intercept, you start off by letting y be equal to 0. So 4 times 0 is 0, of course. 5x equal to 20. And divide both sides by 5. X is equal to 4. So that ordered pair for my x-intercept is going to be 4, 0. So this y equal to 0 is going to be characteristic of all x-intercepts. So if you want to find your x-intercept, no matter what type of problem you're dealing with, you want to find your x-intercept, you always start off by letting y be equal to 0. Then if you want to find your y-intercept, you start with letting x be equal to 0. Plug it in. 5 times 0 is 0. Don't forget that negative is still attached to the 4, so that's negative 4y equal to 20. Divide by negative 4. Y is equal to negative 5. So be careful here. Don't forget, it's when you talk about your ordered pairs, it's x, y. So your x is 0. So it means your ordered pair is going to be 0, negative 5. So those are our 2 points that we will be able to use to graph our line. All right. Any problem with that? Make sure we're okay. All right. So we can go ahead and graph those 2 points. All right. So 4, 0, I will go to the right 4, but I don't move for y because that's 0. And then 0, negative 5. I do not go up to the right or left for x because that's 0, but I go down 5. And that's our line. All right. Any questions? Everybody good? So next, talked about slopes. You can use your slopes to graph. First thing we introduced was a slope formula, y2 minus y1 over x2 minus x1, wherein the x1 and y1, x2, y2 is just 2 points on the line. Let me tell you this. Also, it's rise over run is the other side or the other part of the relationship of your slope that will help you to be able to graph. All right. All right. Scroll up a little bit. Very good. Okay. Let's go. Do I want to do 10? No, I don't want it to simplify. So let's go 8. Nope. Don't want to go 9. I'll go 14. That should be good. So I just want to keep a fraction. I'm just playing with stuff in my mind. So I'm going to find the slope of the line that passes through 1, -2, and 5, 14. Pass through these 2 points. So what you would do, just establish which one you're going to call x1, y1. In other words, which one you're going to call point 1 and which one you're going to call point 2. And then substitute in according to the formula. Y2 is 14. Y1 is -2. Make sure you don't lose the negative. There's a minus sign in the formula. But then also we're substituting in -2. So make sure you don't lose a negative there. And then we have 5 minus 1. Negative to a negative turns positive. So that's 16. On bottom, 5 minus 1 give us 4. See, I meant to make that add anyway. So I end up canceling out anyway. So 16 into 4 gives us 4 as our slope. Questions before we look at the next one? Or the next thing? All right. So if we want to use our slope to graph, first thing we do is make sure that it is solved for y, because that would be considered slope intercept form. So everybody done copying that? So that's y equal to mx plus b, where m is your slope and b is your y intercept. All right. So if your equation, once again, is solve for y, what's sitting in front of x is your slope, and then the other number is your y-intercept. So before I do that, also we said that our slope is rise over run. So that means my top number will tell me to go up or down. Bottom number will tell me to go right or left. And all the stuff that I'm talking about right now, all of that is in those videos that I sent. Just doing, like I said, a little review. So let's see if I want the graph using my slopes. Let's see if I have. Say if I have y equal to 2/3 x minus 4, and I want to graph using the slopes. First thing I recognize is that the number in front of x is our slope. So that's 2/3. And then this other number over here, this -4, is my y-intercept. Now, both of these numbers are positive. I didn't emphasize here that these are my positive moves, up and right. These are my negative moves, down and left. Just like when we're looking at our graphing, the horizontal axis, vertical axis, up is positive, down is negative, right is positive, left is negative. So same thing here. So I have +2 over +3. So that means I'm going to go up 2. And then right 3. Now, this -4 is my y-intercept. So remember I said that for all your y-intercepts, x is equal to 0. So the ordered pair here is going to be 0, -4. So that will always be the case for that number, your y-intercept. The coordinate of that number will be 0 and that number. All right, so we graph it. So you graph your y-intercept first. Always graph that first. All right, so that's 0, -4. So you go down to -4. That'll be right here. And then you generate another point from the y-intercept. So you do this from the y-intercept. You don't go back to the origin. You go to your y-intercept, and then you go up to right 3. And that'll put you right here. And that'll be your line. All right. Questions before we do at least one more?
I was going to ask, can we do one more of these?
Absolutely not. All right, so let's see. Let's go 4. I don't want. Let's go 3x. All right, let's go -3x plus 5. So once again, what's in front of x is your slope. So we have y equal to -3x plus 5. So m is -3. Y-intercept is 5. All right, so don't forget it's rise over run. So I have a -3 here, but any number that stands alone can be rewritten as a fraction by putting it over 1. So we have a -3 over +1. So it's rise over run. That means I go down 3, and right 1. Once again, the order pair here is going to be 0 and the number, so 0, 5. All right, you have enough information to graph now. Once again, you graph the y-intercept first. So 0, 5, you move nowhere forward, left or right, because that's 0, but then you go up 5. And from your y-intercept, from this point right here, not from the origin, but from your y-intercept, you go down 3, right 1. And that's your line. All right, questions, any questions? All right, everybody good? Let me see what else they have going on here. Okay, equations of lines. All right, so they ask us to write the equation of the line that passes through the point -1, -3, and slope of -8. So first thing, recognize that m is equal to -8, and x1, y1, our point, is -1, -3. So those are the variables that are going to be associated with that. All right. So now we're going to use our point slope formula. That's y minus y1 equal to m times x minus x1. All right. So we're going to end up plugging in for y1, m, and x1. So it's going to be y minus, and make sure you hold on to your negative signs, y minus -3 equal to -8 times x minus -1. All right. Any problems with substitution? Go ahead and simplify. I'm just going to make this positive before I distribute. Distribute -8. So -8x minus 8. And subtract 3 from both sides. So y is equal to -8x minus 11. All right, any problems? Any problems? What if the line passes through? Oh, yeah, 5, 6. So if we want to find the equation of the line that passes through 3, 2, and 5, 6, so notice that up to this point, when it comes to our formulas, we always had a slope. So notice this time they didn't give us a slope, but they gave us 2 points. So what we can do is use these 2 points to find our slope, then go back to our formula. So we call the first point x1, y1. Second point x2, y2. So y2 is 6 minus 2, which is y1. X2 is 5 minus 3, which is x1. And so 6 minus 2, 4. 5 minus 3 is 2. That ends up giving me 2 as a slope. Everybody okay? So now we'll go to our point slope formula. Y minus y1 equal to m times x minus x1. Doesn't matter which one of these points you use, they still will give you the same line. Remember, the line goes through both points. I normally just stick with what I've already called x1, y1. But once again, it doesn't matter. So that's y minus 2, so called y1, and then 2 x minus, is that 3? Yep, 3. Any questions? Any questions? Go ahead and distribute. Y minus 2, 2x minus 6, and add 2. And that'll be your answer. All right, questions. All right, so before I go any further, is everybody okay with what I've done, what I've said so far? Okay. All right, so let's look at 3.5. That's the last section in chapter 3 for us. I guess I could have said linear systems of linear equations. Yeah. All right, so system of linear equations. So basically up to this point, we've solved the equations, but this time we're looking at solving a system of equations. And so what that means is that you're gonna have an ordered pair that will work for the system. In other words, this is considered our system of equations. So it's not just one equation you solve for, you solve for two. And one ordered pair has to work for both of them in order for it to be the answer for the system. So in other words, let's say if I wanted to try, and let me write this. So a solution for the system will work for both equations. So what I mean by that, the ordered pair 5, 1 wouldn't be a solution for the system because 5 plus 1, remember x is always the first, y is always the second part of your ordered pair. So 5 plus 1 is 6. Well, 5 minus 1 is not 2. So whatever your ordered pair is, whatever your solution is, it's an ordered pair that will work for both of them. All right. So sure that some of you can already see what the answer is for this one. Solution here is going to be 4, 2, because 4 plus 2 is 6. 4 minus 2 is 2. All right. And so we're going to have methods that we will actually go through that will help us or enable us to be able to solve. So we don't want to have to keep looking at it and just keep plugging in values to try to figure out what the solution is. We're going to have methods that we'll use to help us solve. All right. Everybody good with that before I scroll up? All right. So all right, sorry about that. So there are three methods that we will use to solve. One is we can solve by graphing. Second method, solve by substitution. Third method, solve by addition. And if I'm not mistaken, you guys are not held responsible. I see it here. I'll check before I go into the last method. If I looked at your homework correctly, I did not see that you were held responsible for the addition method. I'll check before we close out though. Before I go into talking about it, I'll make sure I'll look at it. All right, because if you're not held responsible for it, I won't, force you to learn it. If you hold you responsible for knowing how to use it, I'll say it like that. So no matter which method you use, there will be three scenarios possible. First scenario is that you solve and you get one solution. Like the first example I showed you, we end up having 4, 2 as your order pair. That's one solution. It's possible to get no solution. And then it's possible to have infinitely many solutions. So those are your possible scenarios. And also, when you say one solution, you are expected to give the solution. So you wouldn't just write one solution. You do want to write the answer, whatever that one solution is. All right. Questions? Any questions? All right. Let me take a look at this because if I remember correctly, like I said, they didn't hold you to the addition method. Might as well find out now before I get in my flow. Substitution. Okay. Yep. All I see is graphing and substitution. So we'll just look at those two methods. All right. So the first method, solving by graphing. All right. So when it comes to solving by graphing, We're going to graph each equation on the same plane, and then where they intersect, that will be the solution. All right, when solving by graphing, you're going to have, once again, those three scenarios. But I just want to make sure we see how they look when you're trying to graph. All right. So that's your first scenario, one solution. You're going to graph these two lines on the same plane where they intersect. That would be your solution. All right, so the second scenario, you have parallel lines. So the reason why that is important is because parallel lines never cross. So if when they cross, you get one solution. If they never cross, your answer is going to be no solution. Third scenario. So you end up graphing your two lines, they end up being the same line. That's going to be infinitely many solutions. All right. Questions? Any questions? Any questions? All right, so let's look at graphing that first one. We had x plus y equals 6, X minus y equal to 2. We already know our solution should be 4, 2. So if we grab both of these points or grab both of these lines, it should intersect at 4, 2. Doesn't matter which of the three methods you decide to use in order to grab the lines. I'll call this equation 1. This one equation 2. I'll just use XY chart for this one. I'm going to go ahead and solve this equation for y. Just make things easier for me. I normally solve all my equations for y first, and then graph, whether it be plugging in values or using the slope method. So once again, I'm choosing -1, 0, and 1. Plugging in -1 for x. Negative to a negative is positive. So that's 7. Plugging in 0. That's going to be 6. Plugging in +1. Make sure you don't lose that negative. So -1 plus 6 is going to be 5. All right. Everybody good, everybody straight. Do the same thing here, just want to solve it for y. If you have any questions, always feel free to ask. Don't let me just do stuff. If you have a question. So I added y to both sides because my y was negative. And I subtracted 2 from both sides. That gave me y equal to x minus 2. I'm going to use -1, 0, and 1 again. Once again, those points, it's up to you what you want to use. Plugging in -1, I get -3. Oh, still got red. Plugging in 0. I guess I could have put parentheses around that. Plugging in 0. And then plugging in +1. Which would be -1. So before we do anything, questions on what I did, make sure we're all right. So for each one of them, I decided to use XY chart. I just chose -1, 0, and 1, plugged them into the equation, into both of the equations to find the corresponding y values. And now we're going to graph, both of these charts. 2 separate lines. All right. See what happens. All right, so I graphed my first line, got negative 1, 7, 0, 6, 1, 5, so I have to go up a little higher. I think I only went up to 5, 6. So left 1 up 7, 0, 6, 1, 5. Then the next one, negative 1, down 3, 0, 2, right 1, down 1. All right, so my tick marks are a little off. I'm close, like I'm more so closer to 5, 3. But anyway, if your tick marks are right, see how my spacings are off and everything like that. Usually I'm closer than that, but if you got it right, then you would have saw that the ordered pair would have been 4, 2. And see, about when we were in school, we didn't have my math lab, so I would have saw 5, 3 right here, and then I would have had to go plugging in values and seeing what ordered pair is close to that and everything. So a little more of a struggle, but you guys are using my math lab, so once you plug in those values, plug in your points, it'll make your line and everything be straight. So it would have connected at 4, 2. So y'all don't have to worry about that struggle. All right, you will have to generate your points though. All right, questions on the process before we do another one. I want to make sure you're good. Let's see. I don't copy that yet. Trying to see in my mind if that's what I want. Yeah, that's fine. All right, so what I'm going to do is, like before, take my equation, solve it for y. Call this one equation 1. Call this one equation 2. So first thing I would do is subtract 2x from both sides. Then divide by 3. And I solve my equations for y. And also don't forget this 3 has to go to both terms up here. So that's going to be negative 2x over 3 plus 12 over 3. So I have negative 2/3 x plus 4. That's my first equation. See if I can squeeze equation 2 over here. All right, so I'm going to do the same thing for 4x plus 6y equal to 30. I'm going to subtract 4x from both sides. 6y equal to negative 4x plus 30. Divide by 6. Once again, this bottom number needs to go into each term in the numerator. That negative 4 over 6 can reduce down to negative 2 over 3. 30 over 6 is 5. All right. Buddy, all right. All right, so key here. I don't want green, I want red. We see that our slopes are the same. So that means we have parallel lines. Hold on, there's one R. So we already know the answer is no solution. Remember I told you from the scenario that if you have parallel lines, the answer is no solution. Since we have the same slope, which is negative 2/3, that means we have parallel lines. That means we have no solution. Now, my math lab is going to want you to graph it though, but at least you know what the answer is supposed to be. If you have the same slopes, you have parallel lines. If you have parallel lines, that means your answer is no solution. All right. So what I'm going to do is go ahead and graph by using the slope method. All right. So looking at equation 1. I remember once again, you have 3 methods that you can use to graph your lines. It doesn't matter which method you use, you still should get the same line. So this means I'm going to go down 2, right 3, ordered pair, 0, 4. Slope is the same instructions, down 2, right 3, ordered pair, 0, 5. All right, questions on that info before we use it to graph? All right, so graph your, right here, equation 1, graph that point first. So 0, 4, so I'm going up on the y-axis at 4. Then from that point, I go down 2, right 3. Let's see if I can get this straighter than that. One more time. It's okay. And then do the same thing for this line. You start off with 0, 5. So 0, 5 is right here. Down 2, right 3 will put you right here. So you see that our lines have the same slope, same slant. And once again, this means that our answer is no solution. Question on the graphing method before we look at the substitution method. All right, so let's look at the substitution method. All right, so let's look at our steps. All right, first step, solve one of the equations for one of its variables. It does not matter which one. You just want to solve one of the equations for one of the variables. Let's see. Let's see how we see it. So we're going to substitute the result from step one into the other equation, or in other words, the equation not used. So what's going to happen now, you're going to have one variable left, so you solve for the remaining variable. Let's see if they said back substitute. No, they didn't. Okay. Let's go with substitute. All right, so then we'll substitute solution from step three into the equation from step one and solve that. By then you will have your ordered pair. And you can check if you like. Trying to find a good example. Any questions on the directions before we look to do an example? Mm, oh, I got my pages mixed up. plus 92. All right, so that's a good one. All right, so let's go ahead. Okay, so we have 2x plus 4y equal to negative 6. Then we have x minus 2y equal to negative 5. So you always want to choose the easiest route possible to get one of your variables isolated or by itself. Remember, your first step is to solve the equation for one of the variables. So we see here, the easiest one to solve for is x in the second equation. So we'll go ahead and do that. So we're going to use your second equation, and we're going to solve that for x. It doesn't matter which one you solve for, though. If you decide to solve for y using the first equation, it doesn't matter. It's just that you may have fractions involved if you decide to use something else. But this is the easiest route to go. If we add 2y to both sides, we see that we have x equal to 2y minus 5. And that's the end of step 1. We want to solve one of our equations for one of our variables. Now for step 2, I probably should have wrote it up here like this. Step 1, then do step 2. So I'll do it like that. So we're going to start with the other equation. Remember, we started off using equation 2. So now here we're going to go to the other equation, equation 1. And that was 2x plus 4, y equal to negative 6. All right. So we see here that x is equal to 2y minus 5. So that means where I see x, I can plug in 2y minus 5. So x is right here. And that's the end of step 2. And make sure I didn't include that. Yep. So that's the end of step 2. Plug in the equation from step 1 into the other equation. So notice the 2 is there. Plus 4y is still there. Equals to minus 6 is still there in the equation. Just that now we substituted 2y minus 5 in for x, because that's what x is equal to. All right, so go ahead and solve for y. We have y left. Yeah, I'm going to do that. Rewrite it. Distribute 2. 4y minus 10 plus 4y equal to negative 6. Add your like terms. 8y minus 10 equal to negative 6. Add 10 to both sides. 8y is equal to 4. Divide by 8. y is equal to 1/2. Reduce 4/8. Any questions? All right, so now step 4, we're going to take this value of y, plug it back into our equation from step 1. So you go back to step 1, and we have x already solved for. X is equal to 2y minus 5. So I'm going to take that y, plug it in right here. So 2 times 1/2. That's just 2/2, which is 1. And 1 minus 5 is -4. So that is x. So this means your ordered pair is -4, 1/2. All right, questions. All right. Let's look at another one. That's similar to what we just did. Trying to find a good one. Let's graphing. All right, I'll just have to make up one. I don't like the way these look. Let's go with less. We can just use this. That'd be fine. Forget it. All right, we'll just do it like this. Okay, I was looking for a particular one. This book didn't have what I like as far as my setup. I couldn't find my original notes, but we'll go. All right. All right, so we have 7x minus 3y equal to -14. Negative 3x plus y equal to 6. So once again, we want to solve for the easiest route possible, and the ones that they're giving us for substitution. They're giving us these options right here, so we'll take advantage of them. So we'll take our second equation and this time solve it for y. And of course, if you ever see one, or if you see one in your homework that's more involved or has more content in it as far as complications, as far as trying to graph, or not graph, but solve for your variable, and you have questions, always feel free to bring it to class, or like I said, shoot it to me an email, and we will make sure you have your clarity. So step one, we want to take one of our equations and solve it for one of our variables. All right. Step two, I'm going to use equation 1 now, which is 7x minus 3y equal to negative 14. And we're going to plug in y, which is 3x plus 6. And that's the end of step 2. All right. So now we're going to solve that for x. Distribute that negative 3. Combine the like terms. So 7x minus 9x is negative 2x. Add 18 to both sides of your equation. That'll give you negative 2x is equal to 4. Divide by negative 2. Stay black. X is equal to negative 2. All right, problems before we go to step 4. So now we're going to take x equal to negative 2, plug it into step 1. Step 1's equation, which is 3x plus y, 3x plus 6, excuse me. So we're going to take this value, plug it in right here. So 3 times negative 2 is negative 6. Plus 6 is 0. And that should be x plus y. All right. So your answer, -20. All right. Questions? Any questions? All right. So one last thing. How I want to say this. Let me do it like this. So just like when solving your regular equations, if your variables cancel out and you have a false statement, your answer is no solution. And this is the same thing. Remember I told you that no matter what method you use, you have those three scenarios. The two we just did, we had one solution, but this is how no solution is produced. So if you solve it out, your variables cancel out, and you have a false statement. Remember your false statements could easily be 0 equal to 5. That's false. You know, just two numbers that are not equal to each other once your variables cancel. Then your answer is no solution. But if your variables cancel, I should have made this one black then, huh? I wanted to say generic. So then if your variables cancel and a true statement is produced, then your answer is infinitely many solutions. All right. Questions on anything? All right. So, as always, try the stuff out. See if you have any questions. See if you're stuck. Have not created chapter three's test yet, but guys, make sure you are active in my math lab. Trying to knock this work out because I do have to validate attendance and validate your participation. And hopefully you guys saw that email that I sent out. I think 2 weeks ago, last week, something like that. And so I do have to submit, that you guys are active and everything like that. So, and my math lab is the easiest way to, solidify that, even if you don't come to class or, whatever. If you can show that you're active in my math lab, then you're good to go. Anything else before we close today? That's it for chapter 3. All right. So, like I said, try the stuff out. Don't hesitate to contact me if you have any questions. Feel free to email me. And have a great weekend. Have a great week. I'll see you next Thursday. All right. You guys take care.